Hi everyone. Today I'm going to be talking about a quantity in physics called acceleration. And acceleration is basically defined to be change in velocity over change in time. Okay, so change in, I already told you, we denote it by this little triangle called delta, and velocity is v with an arrow on the top, and so we write acceleration as delta v over delta t. Okay, acceleration is often denoted by a small a with an arrow on the top, and as you can see, we have this vector called the change in velocity over sometime that's just a number. A vector divided by a number gives us another vector. So I will go into more detail about why we are getting vector out of dividing a vector by a number. So, like I said, acceleration is change in velocity over change in time. What it means is that if I'm driving with 60 miles per hour and I change my velocity to maybe 80 miles per hour, that's kind of scary, 80 miles per hour in, let's say, 15 minutes, in this amount of time, then the change in my velocity, which is delta v here, is 20 miles per hour. This change in velocity in 15 minutes gives me some number for acceleration. So in this scenario, my acceleration would be 20 miles per hour over 15 minutes. And then if you like, you can convert minutes to hours and whatnot. But I just want to give you an idea of what acceleration means. So as you can see, we basically defined acceleration based on velocity. I want you to be careful about associating acceleration with velocity, however. Although acceleration is defined based on velocity, please be aware and never ever link directly acceleration with velocity. Why? Because you could be going with 60 miles per hour and your car would be on cruise control set at 60 miles per hour and wouldn't change a bit. Therefore, if you are not changing the 60 miles an hour, you are definitely not changing your velocity, and therefore your acceleration ends up being zero. So although the car is moving with 60 miles an hour for, let's say, 5 hours, because it's not changing its velocity, there is no acceleration due to this reason. So the car is moving, it's totally having some velocity, 60 miles an hour. But because that 60 miles an hour is not changing, if it's, let's say, on cruise control, then you are having acceleration being zero. So never associate directly velocity to acceleration. It's not like everything that's moving, because there is velocity to it, we are going to be having acceleration for it. Acceleration depends on the change in velocity. Of course, if you are changing your velocity from 60 to 80 in 15 minutes, you end up with some number for your acceleration. And if you change your velocity from 60 to 80, let's say in 5 minutes rather than 15 minutes, then definitely you're accelerating more, just because 20 in that case would be divided by 5 rather than 15 and gives you a bigger number for your acceleration compared to 20 over 15, right? So acceleration gives you an idea of how much the velocity is changed over some period of time. If you are changing your velocity during a small amount of time, then you get a bigger acceleration. It means that you're pressing on your gas pedal way harder than the first scenario, let's say. Okay? So this is the idea of acceleration. So acceleration is basically change in velocity over change in time. Whenever you're changing your velocity, you definitely are having an accelerating motion in your system. If you are going with the same velocity, however, no matter how fast you're going, you are not accelerating. Your acceleration is dead zero. So get used to it and don't link and associate velocity to acceleration just because of the fact that I just told you. Okay, so that's one fact about acceleration. So this is one thing I would like to talk to you about. The other thing is basically the units for acceleration, and the fact that the reason why I'm saying that acceleration is a vector. So say, I'm going with 20 miles per hour. This is my initial velocity. Let's call it V1. And so this is what I want, I'm solving for. And then I press on my gas pedal and move with velocity equals 30 miles per hour. See the arrows? This is bigger than that. This shows that this magnitude is bigger than this one. So the change in your velocity, or basically V2 minus V1, is now 10 miles per hour. Say I do this change in my velocity over maybe 30 minutes, which is half an hour. So delta V over 0.5 hours. This is miles per hour, and that was 10. So 10 over 0.5, that gives me 20. And now let's talk about units of this 20, which is your acceleration. So as you know, acceleration is delta V over delta T. In SI unit, in standard unit, velocity is given by meters per second. Now time also is given by seconds. So if you work it out, complex fraction, m times 1 over s times s gives you meter per second squared. So in SI system, the units for acceleration is m over second, m per second squared. Now, if I want to do it here, then I have miles per hour for change in velocity, and I have hour for the change in my time. So I go miles per hour squared, and that's good to go. So now if you want to convert the miles per hour squared to meters per second squared, just go ahead. Do either the stairs or do the other method that I explained to you in the first video that I made for you.